Okay, so the next functionality we're going to look at is working with dates in survey data. Um, as we know, dates are funny. We function using the Gregorian calendar. Our dates for a number of for a year has an arbitrary start point. Um, with the Gregorian calendar, the start is sometime within the period when Jesus Christ was born, and it has a Roman heritage. Islamic heritage in terms of working with in units of six. So we have like 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, which is divisible by six. And we then have months. We have 12 months divisible by six. And we also, we're trying to keep our time standard, and we're dealing with the orbit of the Earth around the sun and the seasons and what is a year. And we find that roughly one rotation of the Earth around the Sun is 365 days. It's not quite perfect. We do have to make adjustments to our year. We actually, every 4 years, add a day. And to adjust for that, the orbit around the Sun is not truly 365 days, it's roughly 365.25 days. So things get really wacky when you're dealing with date functions in these databases. And there's different formats that you can use. And to do that, basically these platforms, SPSS, Excel, have to create some kind of uniform metric to measure time. And I mean time in terms of the time period that the distance in time between period 1 and period 2 as determined by date and hour and minute and second. And to do that, they create arbitrary starting points, and they create their own unit of measure. So for SPSS, start is the zero time is October 15th, 1582, which is the date that the switch was made to the Gregorian calendar. So time zero for SPSS is that date at midnight, January 1st, or October 15th, 1582. And then everything forward is the number of seconds that have transpired from that arbitrary starting point. Okay. So, and then to do that, what SPSS does, it anchors dates to that metric. So if I say, today is December 8th, 2021, that date itself at midnight will be associated with the number of seconds that transpired from October 15th, 1582 to December 8th, 2021. And that'll be the unit that SPSS uses. So that if I want to figure out the distance and time between 2 points, 2 dates, I use the number of seconds that have transpired. Okay, so let's just work with this. So SPSS has a whole series of special functions for calculating to work with time. And to do that, I'm going to create transform compute. I'm going to create a variable that's going to be DOB. Now, the cleanest way of storing data in a data file is to record, if you're done this, in our voter database, we have the DOB, the date of birth for each participant. So the year they were born, the month they were born, the day they were born. And it's stored in 3 separate variables. That's typically the cleanest way to do it, right? So what year were you born, what month were you born, what day were you born of that given month. And I can see, well, I won't see it yet. So what I have to do is there's a whole series of function groups in SPSS, and I want the date creation functions. I can say, okay, for each person's date, DOB, tell me how many seconds have transpired since October 15th, 1582. Now, there's a number of functions. There's duplication here in terms of the number of people that have had their hands in the development of SPSS. So there's DMY, which I tell them what variable represents the day, the month, the year for the given date. What's the DOB? I have MDY. It's the same function. They've reordered it. It makes no difference. Okay, so I've just picked the first one, DMY. I need to tell SPSS, okay, in the first question mark, what variable is associated with the day? And in this case, what day were you born is variable Q2C. Then there's a comma, and then I have to tell SPSS the second question mark, what month were you born? And that's Q2B. And then the final question mark will be, what year were you born? And there we go. So use the date creation function, date DMY, tell SPSS which variable is associated with the day, then have a comma, which variable is associated with the month, then have a comma, and then the variable that's associated with the year. And once I've done that, I can go OK. And I should see a variable in my data. There it is. That's the number of seconds that have transpired since October 15th, 1582. Okay, so now I want to put it in a format, so that's great. But SPSS knows, because this is kind of the foundational measurement of time in the SPSS system. So what we have is, if I go to variable view, I can then switch. I go down to the bottom. There's my new variable DOB. It's referred to as numeric. But what I need to do is I need to tell us, but no, it's not numeric. It is a numeric in the sense that it's the number of seconds that have transpired since that start date. But I can tell SPSS, well, look at that, but know that built into the system is the date that refers to those number of seconds. So if I go date function, and I'll just, I can pick a number of options. I'll just pick here, nice clean one. And now if I go and look, the variable is still that number of seconds, but it's overlaid on the view here in terms of the data view, what that represents in terms of date and time. And that's October 2nd, 1945, which is the date of that person, right? Born October 2nd, 1945. And I have that now for every person. Now it is behind the scenes. It's now saying it's kind of like I got the ruler to say that it's a scale variable, but I have it as a type data. So I can see here it's variable DOB, and it's type date, but the measure is scale. Why is the measure scale? Because if I switch it back to numeric, the scale is the number of seconds that have transpired. Okay. Now I'm going to be doing a couple of calculations here. I like that one best. Now there's a feature in SPSS, because SPSS is working with syntax. So what I want is I always want to keep a copy of my syntax that I'm executing, and I want it in my output. So if I edit file, I want to change my settings. I think it's edit. Sorry. Options. I'm looking. So if I go to my viewer, I want to display my commands in the log, and I'll explain why I want to do that in a sec. And what it does is when I execute a function or a compute, SPSS will show me what commands it actually executed in its syntax. So I toggle that on. That's under Options Viewer. Okay. So now when I go to Analyze, I can repeat my transform compute, and then I go, okay, I'm just redoing it. So I'm just going to change existing variable. There, it's created the that's the command that it executed in SPSS syntax. Now I want to see how old that person is as of, let's say, today. So for today, I'm going to pick, let's say, today's the 8th of December, 2021. So I'm going to create a new variable, transform compute, and I'm going to call it today. And now I'm doing day, so today's the 8th. I'm just going to put in a constant of 12 of 2021. So that's going to create a variable that has a value, the same value, a constant for each person, which is today's date. So I can work with constants instead of just variables. So day, month, year. Create that variable. It shows me the syntax. Once again, it's the number of seconds. change it to date, and I'm okay. So now I have two dates, today's date and the DOB date for each individual. I can now calculate how old they are by just taking the difference between these two, knowing that it's type, date, measure, scale, scale being the number of seconds. So if I do the subtraction, if I subtract from today the DOB, it's going to tell me how old the person is in seconds. So transform compute. Okay, so I'm just going to do a simple, I'm going to call it age in seconds. And it is equal to today minus their date of birth. And that's going to tell me how old they are in seconds. And there's the age in seconds. Now the next thing I want to do is calculate how old they are in years. So transform compute. So I'll call it age in years. And it's equal to their age in seconds. And divide that by, take seconds, divide it by 60 to convert it to minutes. Then once I've divided by 60 to convert it to minutes, I got to divide it then by 60 to convert it to hours. Divide by 24 to convert it to days. And then I divide by 365.25 to convert it to years. I do the 365.25 because on average there are 365.25 days in a year, because every 4 years there's 366 days in a year. So now I'll have their age in years as of today. And I look at my value and there's their age as of today. Okay, so now if I, let's say someone comes along, cleans out all my data, boom. I've lost all my work. Now the beauty of it is by toggling on in the output viewer the commands, I can then copy these commands. Come on, little SPSS, come on, little puppy. So I'll take that, control copy, and I'm going to create a new syntax file. So instead of doing it through the drop downs and the pop-up menus, I can copy that, control V, get rid of this. I don't need the execute repeated because I can just do it in one batch. And now I can just simply run this, and it'll replicate my syntax, and all my variables are reproduced. Beautiful thing. Okay, so now what I can do is I've got their age in years. I know those who voted and those who didn't, and I can see, is there a difference in age between those who voted and those who didn't? So this is just a small analysis. I'm doing an independent means t-test. So analyze, compare means, independent samples t-test, and my grouping variable is did they vote or not, and it's 1 yes, 2 no. Okay, so I bring that over. I got to tell SPSS which groups I'm interested in. I'm interested in groups 1 and 2, the yes, no. My test variable is age in years. And then I go, I don't need estimates of X sizes. Then I go, boom. And I can see in my output, Levine's test of equality of variances. It's because the F observed, the null hypothesis is variances are equal, alternate hypothesis variances differ. My F observed for the test is 11.5, P less than 0.05. I reject the null. I go down to the bottom row. My null hypothesis for my test is that there is no difference in age between those who voted and those who didn't. Alternate hypothesis is there is a difference. And I reject the null hypothesis for the two-sided test of significance, P less than 0.001. And I look at my results, and yes, there is a difference. Those who voted tended to be, on average, as of their age today, older than those who didn't. So older people are more likely to vote. Okay. So that's how we work with date functions, and just giving you a little bit of a tip in terms of working with syntax. And sometimes if you can have the syntax, it makes life a lot easier. Then you don't, if let's say this is a survey that results keep coming in and you're continually having to do this update in terms of the DOB and age, and then running a t-test, you can use this functionality here in terms of creating the syntax and running it, so you don't have to always keep looping through the drop downs from the main menus in SPSS.